Hello, my name is Derek from Tomcat Gas Training and welcome to this video on the dying art of changing gravity hot water pump central heating into a sealed fully pumped system. We're also in this video going to be looking at PRIMATIC cylinders, so as usual let's stop messing about and waffling and let's get on with it. So we're on site today and we're going to be replacing this old Glowworm 4560 freestanding balance flue boiler. So there's a few things I want to show you about this job. Now this is gravity hot water pump central heating, but there are a few bits of quirkiness which I haven't seen in a very long time. So we'll have a look at them first before I show you the system. Now the first thing is we found this, and it tells you exactly where everything is, because sadly the old couple who lived in this house are no longer here. So we've just been looking all over the place for the isolation for the fuse spur, and if we turn the next page it's there. So we now know it's under the stairs, so if we go under the stairs we can see it's there. And it even tells us there's normally a red light on when it's working. So let's get it drained, get it turned off, and let's get cracking. Now I don't know if you can see this very well, but that's the drain coming out through the wall to drain the central heating system. And again, when I was apprentice this was quite common, but obviously now it wouldn't be done because the drain is outside the envelope of the building and will actually freeze. But this is now into a new extension, which is going to be changed later anyway. But yeah, always look out round the outside of a 50s built house and see if there's a drain sticking out of the wall, because it'll be for the central heating. Now this is the old glowworm we're removing, balance flue. So the two 28mm pipes you can see here are the gravity circs going up to the cylinder. This is a relief valve which we used to put in gravity circs, so if it went over pressure for some reason it would blow off. So the one you can see here coming off the bottom is the central heating return, and at the back here is the flow. So we've got gravity hot water pump central heating. And if we go across here, the pipes going up the wall there, they are the flow and return for upstairs. So this is actually split into two zones. There's an upstairs zone and a downstairs zone. So there's a manifold downstairs feeding all the rads on 10mm, and then there's one upstairs feeding all the rads off 10mm. Let's go and have a look at the cylinder. So this is the old cylinder. It's only a tiny one. Now basically what we've got here is the gravity flow and the gravity return coming up from the boiler. It's in 28mm to make it work by convection. And what we've got here is an old Drytown valve. Now what this what it does is temperature control the cylinder mechanically. Not seeing one of those for a long time. They actually improved this by putting a stat on the cylinder, so it will be temperature controlled via a file on the cylinder, which you can still get now. But that's a very old Drytown controller. Well, if memory goes, it's a Drytown controller. And that controls the temperature, or tries to control the temperature of the cylinder to make sure it doesn't go over 65 degrees. So again, we've got the flow coming off, vent pipe going up, and then at the back we've got the cold feed going down into the cylinder at the bottom. Pipe you can see here, the 15mm, that's going up to feed the only one system. So if you come to an old job like this and there's only one system in the loft and you can't find an F&E anywhere, and you haven't got any vent pipes or cold feed coming off these pipes, then it's almost certain you've got a PRIMATIC cylinder. So, looks like a siphoning job for this as well, if we can't get the full bubble and everything to drain. Another way of telling if you've got a PRIMATIC is when everything stops draining, so when your heating stops draining and your cylinder is empty, then you know definitely you've got a PRIMATIC cylinder. So we're in the loft, and that's the old feed system going to the cylinder, and you can see it's not lagged, there's no lid on it, so that's not very good. It's not a fantastic platform it's sat on, but there is no F&E up here, so again no F&E points to a PRIMATIC cylinder. So we've got the water off now, we're just draining it down, and then if this, like I say, if the cylinder actually drains completely or most of the way without us having to siphon or drain the cylinder, then we definitely know it's a PRIMATIC, but there doesn't seem to be anything up in the loft to say it isn't a PRIMATIC. So let's have a closer look at this system we've just been looking at. Sorry about the crudity of the drawings on the board, but you'll just have to put up with it. So let's find out what system we've got. So here we have the floor standing boiler. It's a floor standing balanced flue boiler, the one we're taking out. And this is the primary flow to the cylinder, and this is the primary return. And I told you they were 28mm pipe. And the reason they're 28mm pipe is because it's gravity hot water, there's no pump involved here. They need the bigger size pipe to get the flow up quickly to the cylinder. We now have the flow and the return on opposite sides of the heat exchanger. And the reason why we used to do that is so we made sure we used all the heat exchanger, because if we just put the return on the same side here, we would be short circuiting round here. So we used to always put them on the opposite side, so you can see that's the flow for the cylinder, that's the flow return, sorry, for the cylinder, that's the flow for the heating, that's the return for heating. So they would use the full heat side of the heat exchanger. Now we said we had the relief valve. That's the, again, if anything happens with the PRIMATIC, because we've got the PRIMATIC cylinder here, anything happens with the PRIMATIC, then this would start to drip. And you should be able to find these on back boilers and stuff like that. So if we look at the heating circuit, we can see this is the flow pipe. But there's no pump on the flow in this system because it's gravity hot water pump central heating. They used to put the pump on the return. Also, if you try and put a pump on the primary flow to a PRIMATIC cylinder, it will damage the bubble. Also, if you try and turn this gravity hot water pump central heating system into a fully pumped system with a PRIMATIC cylinder, you will also damage the bubble. So with a PRIMATIC cylinder, they can only go on to gravity hot water pump central heating. So there's the return going in. Now, if this wasn't designed by going down first and then going up to feed upstairs radiators, we would have needed an anti-gravity valve here to stop the convection flowing around the radiators upstairs when just the hot water's on. But because they went down first before they went up, they didn't put an anti-gravity valve in. It possibly could have still started to circulate around, but it's unlikely with it dropping down first. So when we did go upwards, we always put an anti-gravity valve in. So if you're changing gravity hot water pump central heating and all the pipes go upwards, always check there isn't an anti-gravity valve there. Now, this anti-gravity valve is basically a non-return valve which works to prevent thermosiphoning. They are fitted vertically into the flow pipe of the central heating above the boiler. They are used to stop the water from thermocycling into the radiators when the hot water is being called for. So the way this anti-gravity valve works is, under low pressure, the weighted or spring-loaded flap inside the valve will close when the circulation stops in the circuit. This is so that water cannot pass through the wrong way. When circulation of the hot water or heating is needed, the power of the water pump causes the flap or the ball to lift inside the anti-gravity valve to open in order to allow the water to flow through to the radiators. It's as simple as that. So the way of telling whether this anti-gravity valve needs replacing is, there can often be excessive amounts of air in the radiators if the valve gets stuck open. The radiators can also get hot only when the hot water is being switched on. If the valve gets clogged up or stuck shut, then the water will not be able to circulate around the radiators when the heating is on, so your heating will stay cold. Again, it's as simple as that. So let's have a look at this cylinder more closely. So this is what we call a single feed cylinder, or its trade name of PRIMATIC. Single feed meaning there's only one system. So the one system allows the water to come in to the cylinder, and the water what's in the cylinder will then feed the central heating. We will have a look at this more closely in a second. So that's the pipe layout for this system. Dead easy to work out, as long as you can get at all the pipe work and you can see where it's going. It's getting rarer and rarer now to see gravity hot water pump central heating. So it was a bit of a treat when I went on the job with Tom a couple of weekends ago. So this PRIMATIC cylinder, or this single feed indirect cylinder, let's go and have a look at that more closely. So let's have a look at this single feed indirect PRIMATIC cylinder. Now basically what it is it's an indirect cylinder, but it's installed as if it's a direct cylinder because there's no F&E system. Okay, so the water from this feed system feeding the hot water is also the same water which goes into the central heating system. So there's our first problem. With these old systems, we could put inhibitor in there. There's no way we can put any cleaning chemicals or any protection chemicals in the system because it'll mix when you initially fill the system with the hot water cylinder. So no doing that. The next thing is you cannot upgrade a PRIMATIC cylinder to a fully pumped system, because if you do, you'll break the bubble inside the cylinder, which we'll look at in a minute. One of the other things you can't do is add a lot more radiators onto the PRIMATIC cylinder. So if you get called to a job and they want to add, they've had an extension done and they want to add more radiators onto the system and they've got a PRIMATIC cylinder, there's every chance it won't work, because as we're going to see in a minute, the bubble inside here is where the expansion for the central heating system takes place. So that's 4% extra, so you're adding more radiators, more water to the system, so the system might be too big for the PRIMATIC cylinder. And yes, you can still buy PRIMATIC cylinders. They're about 300 quid, but you can still buy them. Why you'd want to, I don't know, but you know, you never know. You might still come across them. So we've got 3 cylinders here as we're going along. Let's have a look at this one first. So this is our cold feed coming in. So this is coming from the feed system. Now the water inside the cylinder is cold, and what it's doing is it's filling the heating system through the primary return, because it can't get through the flow yet because it fills through this special bubble. So what happens is there's 2 bubbles here. There's one at the top here and one at the bottom here. So while it's cold, the water comes in, goes up there through the gap. The gap's normally at the top there and flows over the top and then down into the heating system and completely fills the radiators. So when you're initially filling and draining these cylinders, you should always have the hot tap open, because the furthest away hot tap downstairs will get rid of all the air through the top here. Okay, so we can fill it up. So that's basically how it fills up. Comes into the cylinder, through the gap in the middle, over the top, and then down into the return pipe and fills your system. So you'll always have the hot tap open downstairs at the kitchen sink when you're initially filling and draining the system. Like I said, for air. Now then, we're fully filling the system up now in the next one. So you can see the actual PRIMATIC and the air bubble is in the top now. And the system is completely full. The cylinder's full with cold water. The central heating's filled through the return and the flow. You've bled all the radiators. Everything's full. Happy days. But the cylinder is cold. Okay? So this water in there is the same water in there. That's why we can't put these chemicals in. Now when we come to the last one, what's happened now is the water's coming through the flow pipe and it's hot. And this is made of copper, this heat exchanger in the middle, instead of a primary coil, but we'll call it a heat exchanger. And what happens is it forces the air from the top of the bubble to down to the bottom. So you've now, instead of on this one, you've got one air bubble. In this one, you've got two. So what that does now is it separates the central heating system from the cylinder. So the waters won't mix once this bubble's been made. Okay? So if you lose this bubble, what you've got to do is drain the cylinder and fill it back up again. Now what a lot of old plumbers used to do, so old guys like my old fella, if they had any problems with the primary flow and return, they used to take the thermostat out of the boiler and boil the water up. So it would force the water around the gravity circuits. You cannot do that with a PRIMATIC cylinder. If you try and boil a PRIMATIC cylinder, you will break the bubble. It will be useless. Just actually draining this system down can ruin the bubble. You're always running that gauntlet for a 30, 40-year-old cylinder that once you've drained it down to do any repairs or any alterations, you're running the risk of damaging the bubble inside the cylinder. Once it's damaged, it's a new cylinder. Now, this was only 2 weeks ago when we took out that cylinder, so they are still around and about. How many there are still out there? This is probably the first one I've come across in 5 years. So that's a single feed, indirect, hot water cylinder, commonly known as a PRIMATIC. That's how they work. So let's have a look at now how we're going to alter and take out this PRIMATIC cylinder and change it for a combi boiler. Let's go and have a look at that. So this is where the boiler's going in the garage. So there is a few spare for us and there's not much of a gas run, but we will have to change that lead off there, and that is imperial pipe, so we will need to leave that pipe because that's staying for the kitchen. We're running the gas down then to the boiler. Then we're bringing the flow return across the garage, and then we're coming down behind this door and we're going under the floor there, so we'll have to sleeve the pipes going through there. The hot and cold water is here, so we're going to have to go through into the toilet here. That's the cold pipe there, that was the hot, and we're going to have to go up through there. So that's where we're going to pick up the supplies from. So the old boiler's now been removed, just got a few other bits to rip out. The builder's ripped all the kitchen out for us while we've been doing all the other stuff. So everything's now installed, we're just doing all the commissioning checks. A few holes to patch up, all the lagging to do. We're just in the process of commissioning. So that's the hot water pipe we've had to run. This will all be changed again when this all gets changed in here. And that's how we've had to do the cold water. And again, it's all being ripped out and redone this later on by the builder. We just needed to get it on. So that's how we've done the pipe work. So that's where they come through the wall and down to feed the boiler. So, with no hot taps in the house because the builder's ripped it all out, so what we've got to do is, this is what we've made up to test the hot water flow rate. Which isn't very fast. Good job. So that's the flow rate. What's it reading, Tom? About 8. There you go. All we got to do now is get the temperature. And that's how easy it is to convert a gravity hot water pump central heating into a combi boiler and a fully pumped system. Now, a couple of things there. First of all, if you are going from gravity hot water to pump central heating, always check and make sure there's no anti-gravity valve. You'll need to remove it. And also, you've got to kind of be aware of changing it from vented to sealed has its own problems. It will find any leaks you've got. And also, because we've got to flush and clean the systems out, that also can create leaks as well. So these are all the things you have to relay to the customer when you're changing these really old systems over. They do need flushing and cleaning out. So if you want to see how to change a vented system to a sealed system, then we've got a video for that as well. So as you can see from the drawing and you can see from the film how easy it was for us to convert it, you're basically doing away completely with the gravity side and you're just connecting the flow and return off the boiler into the heating, making sure you're going into the 22mm flow pipe and the 22 return, and then connecting anywhere into the hot and cold water system. So if you've liked this video, why don't you give me that thumbs up because it shows me you care, or leave a constructive comment down below. If you've not subscribed to our channel, then please subscribe, and don't forget to hit that notification bell because I release videos mainly on a Wednesday. All I've got left to say is thanks for listening. Thanks for watching and stay safe, guys. Cheers.